another look at my modular test system rack. Some things changed since last time. I rearranged the modules a little bit. I added a couple of speakers left and right to test shortwave radios that has no built-in speaker. And some new modules: battery tester, LED tester, and ring tester. So those I will explain in detail in the other videos. Also working on frequency counter. The digital part is done using FPGA for the counting part. That's more or less done. I had some issues with the input module. I made it a separate plug-in module. I'm now waiting for a new board for a new design of the input module. So then we can continue with that. Another board in the pipeline is a crystal tester, similar to the frequency counter with an FPGA and everything, but to test crystals. The battery tester. I can select the type of battery. I'm going to select the 9-volt battery here. The way this works is that it will measure the voltage in an unloaded condition, then load it for 2 seconds and measure the voltage again. So I can see here the voltage I should get and the load I will apply. So I'll hook up a battery, start the test, and I have 8.23 volts unloaded, 8.08 for 9-volt battery, so this is one to be replaced. I can also go in another mode and I can measure the voltage and then change the load. So 10 milliamps, 4 milliamps, and so on. So this is the manual mode. I can also go into the menu and select an automatic mode, an automatic start. So the measurement will start when I have a voltage across my terminals. So I can just touch the battery with the probes and then it will start measuring. That's it for the battery tester. So I have a bunch of batteries in here up to 12 volt, from 1.5 volt to 12 volt. The battery tester module. In the front, the display, 2 rotary encoders, and connections to the battery. The circuit is ESP32. There's a 16-bit DAC in there, an op-amp. This forms, together with the MOSFET, a constant current sink. So the battery is drained with a constant current. Sense resistors, ADS105, 16-bit 4-channel analog digital converter. So we are measuring the sense voltage, we're measuring the battery voltage, so we can calculate the current. What we do is we measure unloaded first and then in loaded condition for 2 seconds. You see some modification I've done here. The op-amp I used originally had a bit of a high offset, so I changed it to an op-amp with a lower offset. That's all changed in the version 1.1 of the PCB design that is released. So that's basically the battery tester.